I'm recording now. So y'all can see the blank. Maddie, can you see the blank?
I cannot. Everything's just black right now. Oh, there we go.
Okay. So this is the last little thing we're going to be doing. I'm not sure what the last thing is. Ellipses and hyperbolas. We're going to be talking about ellipses, and so this is it. The set of points in a plane, the sum whose, the sum whose distances from two fixed points is constant, and each fixed point is a focus, or the plural is foci, of the ellipse. Now in the parabola, we had, when we had our x and y axis, and we had a parabola coming off the origin, we had a foci that was always going to be inside, so to speak, the parabola. So wherever the foci was located in relation to the vertex, if we were just given the foci and the vertex, then we always knew that a parabola was going to be opening up toward the foci, and then the same distance from the vertex to the foci, we had this line called the directress. So instead of having these 2 points now, we have what we call, that's my mess up, sorry. We have now on an ellipse, on our x and y axis, we have our vertex, and we still have a foci here, a focus, but we also have another focus here. So we have a major axis, and we have a minor axis on all ellipses. The major axis are the ones that are going to house the focus, and I have some little points down here that I'll go ahead and undo so you can see everything. But the foci are going to be the same distance apart from each vertex, and these are the 2 fixed points that we're talking about up here in the little definition. You can also see that I have my x-axis here listed as my major axis, and my minor axis is listed as the y-axis. So the foci are always located on the major axis, which is the longer axis. So here, the y-axis is going to be my major axis, and the x-axis is my minor axis. Finish my thought there. The endpoints of the major axis are the vertex. Now I want to shift this. Tell me which way you can see this better. This way or the other way? Is either one okay, or?
I could see fine in both ways.
Okay. I can't tell which one you can see the most, but I don't guess it really matters when you're looking at it. So I'm going to move ahead, and we're just going to look at some equations. So today's 4/15/20, and this is my second page of notes here. So when we are looking at equations, sorry, I'm going to concentrate on my drawing. You can see I didn't concentrate too much. But when we have the center at the origin, and we have, we know that A is greater than B, and B has got to be greater than 0. Otherwise, we would have something undefined here. X squared over A squared plus Y squared over B squared equals 1. That's when X squared over A squared, that's when our ellipse, the major axis, is going to be on the y-axis. When we have the equation x squared over b squared plus y squared over a squared equals 1, and the same holds true for here. A is greater than b, and b is greater than 0. But the x squared is over the b squared, then that's when the y-axis is going to be our major axis. Now, here, the vertices here are going to be plus and minus a at 0. Then if this is the major axis, then our minor axis is going to be 0 at plus or minus b. And then they say that the foci is going to be plus or minus c at 0, because it's going to be in this one somewhere here between on the x-axis. So that's why c is plus or minus 0. And the equation it gives is c squared equals a squared minus b squared to find the foci. Sorry, there was a nap. So now this is for us when we have the x-axis is our major axis. When we have this one, what's going to change here? So if we look at this and we have our y-axis is the major axis, then our vertices instead of being plus or minus a here with a 0, that lets us know that we're not going anywhere on the y-axis. But here we are traveling on the y-axis, but going nowhere on the x-axis. Then it's going to be flipped. So this is going to be 0 plus or minus a. And remember, these are also called the endpoints. And then our minor axis and major axis. Then our minor axis is going to be 0 plus or minus b. And the foci are going to be 0 plus or minus c. So in your brain, you've got to really be thinking, and this drawing goes with this, you've got to really be thinking about where it's located and sketch it out. You can see how rough and uneven my sketches are, but I can at least tell that my y-axis is the major axis because it's longer than my x-axis here. And in the top one, the x-axis is longer, the vertices are further apart than the points on my y-axis in the top. So just do a rough sketch of it, and then you should be able to see, okay, well, in the second one, on my major axis, I'm not going anywhere on the x-axis. I'm just sitting here. I'm sorry, I did this backwards. Y'all should have told me. You know I'm going to do something wrong every time, so y'all just catch me and tell me. I'm just making sure you're awake. So then the foci are going to be at 0 plus or minus c, and the equation's still going to be the same. C squared is going to equal a squared minus b squared. Now, in the book, it shows you how they actually went through this whole premise to prove all of this. I'm not going to go through all that, but if you need to look back and see, that's fine. I don't blame you. But just so you know, it is there, and you can kind of figure out, oh, that's how they came up with all of that. But let us look at now, Maddie, if I leave out something important, just let me know, because I'm trying to get this in before class.
Okay.
So if we look at the equation 4x squared plus 9y squared equals 36. Then our equation tells us, back here, our equation told us that we wanted this to always equal 1. So to get this to equal 1, I'm actually going to divide everything by 36. So I divide each term by 36. And we know that 4 goes into 36 9 times, 9 goes into 36 4 times, and 36 goes into 36 1 time. So then I'm left with x squared over 9 plus y squared over 4 equals 1. So this ellipse is actually centered at the origin. So if I plot this, if I take the square root of this, then I know that this is going to be, x is going to be plus, my x values are going to be plus or minus 3. My y values are going to be plus or minus 2. So if I plot this, I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. And so I've got plus or minus x, plus or minus 2, and so this is my ellipse that I've drawn. So the domain for this, we're always asking for the domain. The domain is going to be -3 to 3. The range is going to be -2 to 2. Now that tells us our domain and range, and by graphing it, I can tell, since this is the origin and it's centered around the origin, I know that my x-axis now is going to be my major axis. So I know that my -3, 0, and 3, 0 are going to be my vertexes. Now I want to know what my foci are going to be. So we went back and we said that to find the focus, or the foci, it was c squared equals a squared minus b squared. And since I'm looking at this and saying that, remember we also said that a was going to be greater than b and b was going to be greater than 0. So since 9 is greater than 4, then this is going to be my a, and this will be my b. So x squared over a squared plus y squared over b squared is going to equal 1. And in this case, a squared equals 9, and b squared equals 4. And the equation says that c squared equals a squared minus b squared. So we're going to have 9 minus 4. I'm not squaring these or taking the square root. I'm taking their actual value. Equals c squared. 9 minus 4 is 5. And that's c squared. I'm going to take the square root of both sides. So c now is going to equal plus or minus the square root of 5. Now the square root of 5 is going to be a little over 2. So now my foci are going to be negative square root of 5, 0, and positive square root of 5, 0. Now the first equation said it was x squared plus 4x squared plus 9y squared equals 36. So this looks like, just looking at this, that y would be my major axis because it's larger. But remember, we have to divide by whatever we're equal to because we want our equation to equal 1. So when we do that, then that makes my a squared equal 9, and my b squared is going to equal 4. So any questions?
No, ma'am.
Okay. So we've had an equation and we've actually graphed it. So what happens if we want to find the equation? So you're given that the origin is at the center. The foci are at 0 plus or minus 3. And the major axis length is 8 units. So the major axis length is 8 units. That means that it's 8 units totally across from endpoint to endpoint, not just from the origin out. It's actually total 8 units across. So we know that if we say that 2a equals 8, because we know that we've got to have from the origin, we've got to have the same distance on both sides, then a is going to equal 4. We know that c squared equals a squared minus b squared. So if c is 3, then we know that 3 squared equals 4 squared minus b squared. So we have 9 equals 16 minus b squared. If I subtract the 16, I'm going to have negative 7 equals negative b squared. And I'm just going to divide by negative 1 because I don't like having a negative. So 7 equals b squared. So we have a positive square root of 7 and a negative square root of 7. So our domain is going to be the square root of 7. The domain is going to be negative square root of 7, positive square root of 7. Oh, sorry, brackets. And then the range is going to be negative 4, 4. Now when you're looking at this, we've got the square root of 7 is going to be the length from the origin out, and then 4 is going to be the length from the origin out. So the longer side is going to be the x or the y axis. Or sorry, 7, the square root of 7 squared and 4 squared. So 16 is going to be on the y-axis, and so this is the final equation, is y squared over 16 plus x squared over 7 is going to equal 1. So let's go back to something easier here. I'm all for easy, people. I hope that's okay with you, Louise. I guess Louise fell asleep on me. So why don't we look at 4x squared plus 25y squared equals 100. So find the coordinates of the foci, give the domain and range, and then graph it. Just sketch out a graph. So the first step is the equation needs to equal 1. So we need to divide everything here by 100. So now we have x squared over 25 plus y squared over 4 equals 1. And we can actually, since these are squares, we can actually say x squared over 5 squared plus y squared over 2 squared is going to equal 1. And the center is going to be 0, 0. And because we have 5 is greater than 2, then we have A is going to equal 5 and B is going to equal 2. Because remember, A is always greater than B and B is always greater than 0. So you always look here to determine what's going to be your A and B. Since 5 is greater than the 2, then we know that we've got our major axis is going to be the x-axis, is going to be the horizontal. So when we go to graph this, two, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2. So this is the graph of what we have here. So we know the domain is going to be -5 to 5. Our range is going to be from -2 to 2. And if I ask what the foci are, then we know that the foci is going to be c squared is going to equal a squared minus b squared. So c squared is going to equal 25 minus 4, which is 21, equals c squared. I take the square root. So c is going to equal the square root of 21 and the negative square root of 21. Now, because I know the foci are going to be here, I know that my x is going to equal this and my y is going to stay at 0 because I'm not going anywhere up and down on the y-axis. So I have the point square root of 21, 0, and negative square root of 21, 0. Sorry, there we go. Okay? So let's just do another one for kicks and giggles. 49x squared plus 9y squared equals 441.